All right, so now we're going to move on to talking about what the mole is and then doing something called mole conversions. All right, we're going to do mole conversions today and next class. Today we're going to tackle one-step conversions, and then next class we'll do two-step conversions. All right, so what a mole is. Way back when, there was a guy named Amedeo Avogadro who figured out that how many atoms are in 12 grams of carbon-12. It is an insanely large number of atoms. All right. The mole is a counting number. Actually, before I get into how many atoms there are, the mole is a counting number. It's like if I said I have a dozen eggs, how many eggs do I have? 12. I have 12 eggs. The word dozen is a substitution for a specific number. If I said I have a score of eggs, that means I have, does anyone know what a score is? 20 eggs. All right. A score is a word that will substitute for a specific number. The mole, or a mole of eggs, means I have, in particular, 6.02 times 10 to the 23rd eggs. It's just a substitution for a specific number. But that number is huge. That's 602 and then 21 zeros after it. So it's 602. Whew. It's a lot of zeros. I'll even put in the commas to make it easier. It's a huge number. Okay, it's unfathomable how many atoms are in a mole, or how many particles are in a mole. Huge number. Okay, that just goes to show how tiny atoms are. All right. So we call this Avogadro's number, named after the guy Amedeo Avogadro, who figured this out. And yes, I know Avogadro makes you think of avocado. That's fine, but it is Avogadro. What are avocados made generally for? To make guacamole? I didn't get as big of a reaction out of you guys as I did in 7th and 8th. Disappointed. So this bullet point here is why we can make the substitution from AMU to grams per mole. I'm not going to be testing you on any of this. This is just more of an aside, like the derivation. You don't really need to know it, but if you, like, it's there if you want to read about it. Yeah, it's how we can make the substitution to grams per mole from AMU. All right? So, are we good here? Is anyone still writing? You had like 4 things to write from this page. Okay, so Avogadro's number and the mole, we can now talk about converting between different types of units. So this is called the mole roadmap. What does it say at the top of that page? You have to memorize this. You have to memorize it. And I feel this is an easier thing to memorize than any of the stuff from Unit 4 because we're going to do so many practice problems with it that instead of memorizing it, you're going to end up just learning it. Okay? So we can use the mole roadmap to convert between units like a particle, for example, an atom, a molecule, a formula unit, to moles, or moles to mass in grams, or moles to volume in liters. Okay, we can do 3 types of conversions today. Well, next class we'll talk about 2 steps. So, but today we're either going to be converting to or converting from a mole, or the mole. Before we get into some conversions, let's talk about the mathematical definitions, which are actually already listed out here on this mole roadmap, but we have it written down here. All right, there are 3 mathematical definitions of a mole. The first one is 1 mole is equal to 6.02 times 10 to the 23rd particles, where a particle is a molecule, an atom, a formula unit of ionic compound, or an ion. Okay? Remember, that's Avogadro's number. 1 mole for gas molecules also takes up 22.4 liters of space. Now, there's a caveat to mathematical definition number 2. 1 mole taking up 22.4 liters of space only is true for gas molecules, which it says this here, and only works at standard temperature and pressure, or more commonly referred to as STP. Until we get to Unit 8, you will not have to worry about things that are not at STP. So through all of Unit 6 and all of Unit 7, we are going to assume that every gas is at standard temperature and pressure. In Unit 8, we'll define what is standard temperature and what is standard pressure, and we'll talk about how to deal with if it's not at STP. But for right now, just kind of keep that in the back of your mind, the STP stuff. Like I said, you don't have to worry about what STP means. You don't have to worry about what the conditions are, what is standard temperature, what is standard pressure. You don't need to worry about any of that for right now. Okay? And then 1 mole of a substance, the mass of 1 mole of a substance will be the molar mass from the periodic table of that element or of that compound. So like what we learned last class and what we reviewed at the beginning of this class. Okay? So those are our 3 mathematical definitions. You'll see that I'll often write this as MM on the PT, which stands for molar mass on the periodic table. So MM on the PT. All right. So now we're going to go through the conversions, which are similar in style to metric conversions, which we did back in Unit 1, that I know you all loved so much. I'll tell you guys this now. Typically, my students have told me over the years that they prefer mole conversions to metric conversions. And I think that's because you come into the class knowing a little bit about metric conversions, whereas you probably have never heard of a mole before this class. Or you might have heard of it, but you really didn't know what to do. So I think the fact that you're coming in with a clean slate on this really helps. Okay? All right. We ready to move on to the first problem? All righty. Number 1, we're going to convert 4.3 grams of sodium chloride, NaCl, to moles. So it helps if we write out our given and our unknown, UNK means unknown, and kind of map out how we're going to do the problem before we do it. Kind of organize our thoughts. Kind of like in English, you might do an outline before you actually write your essay. We're going to outline how we're going to do the problem before we do it. It'll help you, okay? So our given is whatever is given in the problem. So 4.3 grams NaCl. Like I said before, UNK stands for unknown. What are we converting to? Well, this one we're converting to moles of NaCl. And yes, MOL is the abbreviation for moles. Chemists are lazy. And apparently MOLES is way too long of a word to write. So we just write MOL. All right, I'm going to flip back to our roadmap for a moment. So on our roadmap, we're going from grams to moles, right? Grams is mass. So we're going from mass to moles. Mass to moles. And the piece of information that's going to help us convert from mass to moles is the mathematical definition of a mole in mass, which is MM on the PT. So we're going to use the mole. Go to the next page. We're going to use the molar mass from the periodic table to convert from mass to moles. Okay? So now we're ready to start. Now we're ready to set up our work. The unit you're given is always going to be what you start with. And we're going to multiply that by a fraction. And our fraction is going to be our conversion. Whatever unit you start with, always put that on the bottom so it'll cancel. Okay? Because remember, in math, if you have x divided by x, it cancels out, right? It becomes 1. We have grams. We don't want grams. We want to convert from grams to moles. So grams need to go on the bottom so that it'll cancel out. So grams NaCl on the bottom. And whatever unit you're going to goes on the top. So moles NaCl go on the top. And we're going to fill numbers in front of these units. That's why I left space. Okay. Now look at our mathematical definitions. All of these mathematical definitions were relating to how many moles? 1. All of these were the relationship of 1 mole to something else. All of these are equal to 1 mole. So for all of Unit 6 in your conversion, you're going to put 1 with moles. Okay, we're learning the basics right now. In Unit 7, we'll make it a little bit more complex. We'll do other stuff with it, so that's coming up. But for right now, always put a 1 in front of moles in your conversion. Now, the number that goes with grams is going to be the molar mass from the periodic table. Now, if this were a problem on your test, I don't need you to show me the work on how you calculated the molar mass of sodium chloride for your mole conversion, because I'll know if it's right or not, because there's only one answer. Like, I'll know if you calculated it right or not. But if you need to, off to the side, write it down, that's fine. Okay? So sodium on the periodic table has what mass? 22.99. And chlorine's mass on the periodic table is 35.45. So when you add them up, what do you get? $58.44. Remember, you have a calculator. I mean, it's great that you can do it in your head, but you can, yeah, for the test, definitely use a calculator. You don't want to get points off for making a simple math error. It's happened. It's definitely happened. So yeah, 58.44 is what goes here. All right. And so now we're done setting up the problem. Like I said before, grams of NaCl are going to cancel out because it's on the top and the bottom. And we're going to be left with moles of NaCl. So really, mathematically, what you're doing is taking 4.3 and dividing it by 58.44. Sig figs. Always look at your given for your sig figs. How many sig figs are in your given? 2. This has 2 sig figs, so our answer needs to have 2 sig figs. Okay. So when you do 4.3 divided by 58.44, what do you get with 2 sig figs? A really small, okay, what do you, are you trying to do it in your head? But yes, I'm glad that you can recognize that it's a small number because you're doing basically 4 divided by like 60. What do we get? 0.074? 0.074. And then what are our units? Moles of NaCl. Okay? So that is a mass to mole conversion. We're going to skip number 2 for right now. We'll come back to it when we do some individual practice or pod practice, because it's just the opposite. That's a mole to mass. I want to skip number 3 as well. You guys will do that one in your pods in a little bit. Let's jump to number 4. Number 4. All right. Let's write out our given and our unknown and go from there. So our given is 0.0156, sorry, not 0.01, 0.156 moles of carbon dioxide. How do I write carbon dioxide? CO2. And what is it asking me to find of carbon dioxide? molecules. Now, molecules, that's a really long word to write. And like I said, chemists are lazy. I mean, we abbreviate moles. So molecules, when you abbreviate it, the general accepted abbreviation for molecules is MLCS. You can abbreviate it however you want. Just don't abbreviate it MOL because that's the same as mole. If you abbreviate it something other than the accepted abbreviation, please just make note of what it is. Like define the abbreviation at the beginning of the problem and then you can use it throughout. Kind of like in an English paper, if you were to shorten something or abbreviate it, you have to define the abbreviation first and then you can continue using it further on, right? All right, so that's our unknown. So in our roadmap, where are we starting? We're starting at moles, and where are we going? To particles, because molecules is a type of particle. So we're going from moles to particles. And what information, we're not going to use the molar mass here because we don't have mass. You only use the molar mass when you're converting to or from grams. Since we don't have grams at all, we don't have mass at all, we have to use something else. What are we going to use this time? Avogadro's number. That's 6.02 times 10 to the 23rd. Because that's how many molecules of CO2 would be in 1 mole of CO2. All right, now we're ready to set up the problem. So for our work, 0.156 mole CO2, we're going to multiply that by a fraction. Remember, whatever unit you start with, you want that to go on the bottom, so it'll cancel. So what are we going to put on the bottom in this problem? Mole CO2. And the unit we're converting to goes on the top, so molecules CO2 on the top. What number are we going to put with mole? 1. Because remember, all of these relationships are referring to 1 mole of the substance. And how many molecules of CO2 are in 1 mole of CO2? Avogadro's number, which is 6.02 times 10 to the 23rd. Okay? And mole CO2 cancel, we're going to be left with molecules. How many sig figs are we going to have in our answer? 3 sig figs, because 0.156 has 3 sig figs. Now, before you start calculating this, let's review how to do scientific notation in your calculator, because I know it's been a hot second since we've done anything with the calculators in this class. So, when you're typing this, so you're going to type in 0.156 times 6.02 second comma. Remember, the comma is found above the 7 button. You're just going to do second comma, so it'll look like this. This is how it's going to, right now, this is what your calculator should have. And if you don't include the 0 in front of the decimal point, it won't make a difference. It should look like that. Notice I didn't type times or 10 or the caret. I just did the E. And then you type the exponent, 23. So it'll look like that. Okay? And then enter. It will give you, this is what the calculator is spitting out, 9.3912 E22. Well, the calculator, I know that some of the fancier ones you can actually make it do sig figs, but for the most part, it's not intuitive for the calculator to do significant figures. So you have to tell it, or you have to, when you pull the number from the calculator, you have to round for sig figs, and you also have to indicate what this E means. Okay? So how many sig figs did we say? 3. So 9.39, and then what does that E mean? Times 10 to the 22nd. Okay, you cannot leave that E. You're not a calculator. You have to show me that that E means times 10 to the. And then our units are molecules of CO2. And that's our final answer. And again, we want to clearly indicate our final answer. If you couldn't type it in correctly, when we're doing pod work, I'll come around and I'll help you again, okay? All right, we're going to do one more problem as a big group, and then I'll let you guys do the 3 that we're going to skip over as a pod. Ready to go to the next page? All right. Last problem together, we're going to do number 5. You guys as a pod will have to do 2, 3, and 6. All right, so number 5. What is our given? 0.53 liters of NO2. And what are we asking to find? Moles of NO2. What type of measurement is a liter? It's a volume measurement. So this is the third definition, the third part of that roadmap. Now we're going from volume to moles. So when it involves a mass to mole or mole to mass conversion, we use the molar mass in the periodic table. When it involves particles to moles or moles to particles, we use Avogadro's number, the 6.02 times 10 to the 23rd. When it involves volume in moles, we use 22.4. Another number. There's only 2 numbers you need to memorize during this unit, and that's 22.4 and 6.02 times 10 to the 23rd. And make sure you know when to use them. All right. So we're setting up our problem, 0.53 liters NO2. What unit goes on the bottom? Liters NO2. And what unit goes on the top? Moles NO2. What do we put with moles? 1. And what do we put with liters? 22.4. Because any gas, now this is all at STP, and again, you're not going to have to worry about non-STP for a while, but any gas at STP will take up 22.4 liters of space. Well, 1 mole of any gas at STP will take up 22.4 liters of space. So we have about half a liter here, so it should take up about, oh no, sorry, I was thinking we had half a mole. If we had half a mole, it would take up half the space, but this is going to be significantly less than 1 mole, right? So liters are canceling. We're left with moles. How many sig figs? 2. That starting 0 doesn't count. Yep, so just whatever's after the decimal point. So 0.53, so 2 sig figs. So what is our answer with 2 significant figures? 0.0 what? 24? 0.024. This would be nitrogen dioxide because there's no charge. If it was NO3 minus, it'd be nitrate. Okay? So as a pod, I want you guys to go through and do 2, 3, and 6. And I'll come around and monitor, and I'll check the status of your problems and help if you need it, okay?